Hey everyone, welcome back to MLWorks. In this video, we'll learn about hyperparameter tuning using sweeps, which is a module from Weights and Bias. And we'll talk about sweeps overview, understand how to implement sweeps in your local machine, and log your results to Weights and Bias platform. Now, there are three steps to sweeps for hyperparameter tuning. First, you have to define the sweep, which is the configuration that you have to set for sweep initialization. So defining the sweep requires the search strategy that you want to utilize for searching through the hyperparameter and what are the different hyperparameter you want to tune, and then also the metric against which you want to tune for. Now with that, you have to, once you have defined the sweep config, you want to initialize sweep with this specific command, which will generate a sweep ID. And once the sweep ID is generated, then you can use agent from weights and biases and then kickstart your hyperparameter search for the training job. So with that, let's get started with our experiment. So here we have importing our packages first, and then we log in into weights and biases. So let me run this. So if you see here, I got something called as true because in the backend I have API key which has been referenced by weights and biases here in the VS Code. But if you're doing it from your end for the first time, you have to go and pick your API key from this your account, which is this one I have created here in weights and biases, and under my profile you will have the API key. So once you take that, you have to paste it here when you're doing it for the first time. So once you have logged in, then you can start with the definition of sweep. So we'll be defining a bunch of stuff. One is the search strategies, one is the metric and the different hyperparameters, and some static parameters where you have only one constant value being used, and also how to set the hyperparameter using a distribution. So first let's talk about sweep config. For sweep config, first what we set is the search method, which is random in nature. We can also try out grid or Bayesian method for search strategy. And the loss metric we want to track or optimize for is the loss metric, where you want to minimize the loss while you are trying to search for the hyperparameter. So let me run this first, and then this one. So we are setting the we keep updating the sweep config as mentioned here. So first we created one JSON here or dictionary, and then we updated the metric here with the key metric. And these are the different hyperparameter we want to search through. One is optimizer, the layer size, and the dropout. And these are the list of values the experiment will take values from. And this is the static value that we are setting, which is the epoch is equal to value 1. This is also updated into parameters dictionary. Now if you see here, we have kept a list of values, and only this list of values can be picked up. But there is another way to select a value, for example with the help of distribution. For example, in learning rate, so we are using uniform distribution, and the min value is 0 and max value is 0.1. This is a uniform distribution, so it can take any value from between this min and max for the learning rate. Similarly, for batch size, we have min and max of 32 and 256. And a step of 8, it can take 32, 40, 48, 56, 64. So in that steps it can take, and maximum it can take is 256 as the batch size. And this is one way of selecting a random value for your experiment. So let me run this. Now we have we are done with sweep configuration. This is the first step is done. Now what we want to do is we want to initialize the sweep. So we have to just do weights and bias.sweep, pass the sweep config and the project name, and get the sweep ID. So this will generate the sweep ID. Now this sweep ID is being used for running the experiment, and for that experiment you want to keep track of all the hyperparameters. So this is done with the help of sweep ID. Now before we jump start to the third step where the agent is triggered, we have to set our ML code where we'll be calling building data set or data loader, and then building the neural network and building the optimizer. And this is a function train which takes a config parameter, and this is where we initialize our weights and bias run. And here we log our losses after every epoch. So this is the code for ML, and here we do a bunch of stuff with respect to ML code. So we have declared three functions here: build dataset, build network, and build optimizer. This will create a dataset loader, and then this will create a neural network, and this will create a optimizer. Once that is done, then if you see here, right, in the train function, we also have something called as train epoch. This is where we'll be updating the parameters in this specific function. So if you go into train epochs, you will see we are iterating through the data set, and then we update the parameters. So all this is happening, which is a general deep learning training process. Once this is done, you will get the loss, and which is getting stored here. If you see here, right, average loss, this is getting stored here, which is getting logged by weights and bias again. Once this is done, what we can do is we can run the agent where we'll be passing our sweep ID and the train function. And we want to run this train function 5 times. The sweep ID we got from here earlier. This one is the sweep ID, and this is the train function which we want to execute 5 times. Though we want to run 5 times, okay, so this will be running 5 times then. Okay, it will be running 5 run experiments will be happening, and the train epoch will be called 5 times also. So let me run this now. So this is the first experiment and its corresponding hyperparameters. So first batch size is 40, dropout is 0.3, epoch is 1, and the FC layer size is 256, and this is the learning rate and corresponding optimizer. And this is the batch loss, and this is loss, and this is batch loss, and this is the epoch number, which is 0. Now similarly, there will be 5 experiments with 5 different set of hyperparameters that is getting created or executed. So this is 1, this is 2, and then this is 3. So if you see, right, while this is getting executed, it is showing all the project URL where you have to go and check how the execution is happening. And you also see the sweep and value, okay, sweep URL, or this is the run URL. So these are like, you're tracking your experiments. Under this URL, you will be able to find those experiment details. And while this is also happening, while this is getting executed, right, it is also uploading all the results back to weights and bias platform. So let me go here and go to the project, view all. So it is, let me refresh it. This is 34 seconds ago. Let me click this project's PyTorch sweeps demo. So under when we are initializing sweep ID, I guess, here, right, sweep ID, we gave the project name PyTorch sweeps demo, and it took that name and created this, all the plots under it. So if you see, of all the 5 experiments that we did, the minimum loss was curious sweep 1, which is the first experiment. The second one was 0.52, first one was 0.43, this is 9.3, this is 3.0, and 1.5. So the first experiment was the best experiment, and the corresponding batch loss is present here. Now, what I wanted to show is the sweeps, because this is what the whole task is. Under sweeps, we'll be having all the details regarding each of that experiment that we have done. First thing I want to show is this one, which is the parallel coordinate plot, where you will see batch size, dropout, FC layer, learning rate, optimizer, and what is the metric. So if you see here, this is the metric which is minimum. Finally, where we are using Adam as the optimizer, and which goes on to use either learning rate of 0.06055 something, and here point something 0.02 something. Okay, some value in between 0.05 to 0.000. Then it goes on to use the 256 as the layer size, and dropout has 0.04 and 0.3, and then this is the batch size. Now this is pretty confusing if you see it like this to get the exact number. So what we can do is we can select one specific experiment and get into the details. But before that, let's understand this plot as well, where we have, so let me maximize this one. So here you will notice for corresponding loss rate, the loss metric that we want to minimize, what are the important hyperparameters. This is FC layer size is important, learning rate is important, batch size is important. This is the importance parameter for each of the hyperparameter. Now let me click this one also. So for loss, this is the sweep 1 where the loss was 0.43 and the rest of them are little more than the first experiment what we did. So we don't want to see that. So one more thing, right? Let me go back here, sweep. Okay, we are interested in sweep 1 actually. So let me go to sweep 1. What was the corresponding value of each of those experiment? So let me click this again. And is it possible to save this? Yeah. So if you see here, right, you can download this specific set of parameters also. So let me download this as a CSV. And here you will notice batch size was 40, 0.3 is the dropout, 256 is the layer size, this is the learning rate, and this is the optimizer, and this gave me the minimum loss for me for the experiment. Now you can save it as a file also if required. Now let me go back here. Okay, so is it possible to create a report? So let me create report. So create report, and I want to since I have done the experiments, I want to store them as some report and such that I can share to the users, other users or other team members. So I can set the take the parameters, which is batch loss, epoch. I'm not interested in epoch because it is only one value, loss. Now once that is done, I got these two plots. Now I can publish this project, or I can save this. I can download the report and then share it across to the team, and also edit the report. What is the title of the report and all those things. Add some description and go ahead and save it. So we are at the end of the video. So we'll see in the next. Thank you for watching.